and the refraction of the light. We stopped at the light reflection and I hope to study it very well as we said before. Now we are going to continue the light refraction. The light refraction, we took it in the primary 5. If you remember this experiment, yes, of course you remember it. When you put the pencil inside the cup full of water, you saw or you imagine that the pencil is broken. And we said it before, this is due to the light refraction. What is the light refraction? It is the change in the direction of the light rays when the light passes through two transparent medium. We said the light that emitted from the electric lamp, it will be passed through the air from the above surface of the beaker, and it will pass also through the water. So this is the two transparent medium, the air and the water. But these two transparent medium, each one has a different optical density. What do I mean by the optical density? It means the speed of the light waves through these two transparent mediums, through air or through water. So again, what is the mean by the light refraction? It is a change in the direction of the light waves when the light passes between two transparent medium with different optical density. Let's continue. What is the mean by the optical density of the medium? It is the ability of the transparent medium to refract the light. Again, what is the optical density of the medium? It means ability of the air or the ability of the water to refract any light rays that falls on them. Now let's continue. Each transparent medium has its own optical density. What means it has the speed of the light waves in the air is different from the speed of the light waves in the water. And so we said the air has optical density different from the optical density of the water. So there is a direct relationship between the optical density and the speed of the light waves that pass through them. Let's continue. The concept related to the light refraction. As we said before, we have the angle of the incidence. Before we talk about the angle of the incidence, we have this experiment. We have also here a glass, and here we have the laser beam. The laser beam will be affected by a specific angle of this glass, and we found the incident light ray, and here we have the light ray which passed through the glass, and here it will be called the emergency ray. First, this is the incident refracted ray, and this is the reflected, and this is the emergency ray. The angle of the incidence, again, it is the angle which lies between the incident light ray and the normal line. This is the angle of the incidence. And also we have the emergence or the angle of the reflection. What is the angle of the reflection? Here it is the angle of the reflection. Here it is the normal line, and here it is the angle of the reflection. It is the angle which lies between the reflected light ray and the normal line. And here we have the angle of the emergency. What is the angle of the emergency? This is the angle of the emergency. We found that the angle of the emergency, it is the angle lies between the emergent light ray and the normal line. So again, here we have in the light refraction, we have three angles. Angle of the reflection, and the angle of the refraction, angle of the incidence, angle of the refraction, and the angle of emergence. Let's continue. The law of the light refraction. The law of the light refraction, first, when we said the light ray travels from the from the lower optical density like the air transparent medium to the higher optical density. The ability of the light ray to move by lower speed in the air than the speed in the water, which means that the light waves its speed in the air lower than its speed in the water. So the optical density in the air, it will be more or less than the optical density in water. Let's continue. What happened? Here we have the light ray which moved through the air like this activity. In the light ray which moved through the air, we found the refracted light ray will be nearer to the normal line. It will be nearer to the normal line. Remember, this is not related to the light reflection. In the light reflection, we said the angle of the incidence equals the angle of the reflection. But here in the light refraction, the angle of the incidence not equals the angle of the refraction. The angle of the incidence here will be bigger than the angle of the refraction. Why? Because the optical density of the air is lower than the optical density of water or the glass. Let's continue. What happens when we converse it? When the air travels from the higher concentration to the lower concentration. We will find that it will be refracted far from the normal line. If you see here, it refracted far. The last page, here it's very near to the normal line. In the second one, the refracted ray, it will be far away from the normal line. So the angle of the refraction will be more than the angle of the incidence. When I'm going to ask you like the light reflection, what happens when the incident light ray falls perpendicular to the normal line? We will find, or we said, it will be reflected without reflection. And the same case in the light refraction. It will be refracted or it will be passed without any refraction. Let's continue. The absolute refractive index of the transparent medium. What is the absolute refractive index? It is the rule which can calculate the speed of the light waves in the transparent medium related to the speed of the light waves in another transparent medium. This is called the absolute refractive index of the transparent medium. Again, what is the absolute refractive index? It is the ratio between the velocity of the light through air to the velocity of the light through another transparent medium. And we can calculate it by this rule, the absolute refractive index equal the velocity of the light in the air over the velocity of the light through any transparent medium. Let's continue. When I'm going to ask you, if the absolute refractive index of transparent medium is high, this means that it has a high optical density. And also, the speed of the light will be decreases and the light refract will be increases. So, we have direct relationship between the absolute refractive index and the speed and the optical density, and inverse relation with the speed of the light. Let's continue. When I'm going to ask you, the absolute refractive index must be greater than 1. Why? You will answer because the velocity in the air is always greater than the velocity of the light through any transparent medium. Again, the velocity of the light in the air is greater than the velocity of the light rays through any transparent medium. So it must be greater than 1. Let's continue. The natural phenomena related to the reflection and the refraction. First, the apparent shapes of the object. Second, the apparent position of the object and the mirage. Let's start with the apparent shapes of the object. As we talk about this one, the pencil, when we put in the beaker, we found it will be seems broken. Why? Due to the refraction of the light. What is the interaction or explanation of this? When the light falls on the part of the pencil on the upper part in the air, the transparent medium which has a high optical density, it means the speed of the light will be decreases. While when the light falls on the water, which is another transparent medium, it will have a lower optical density and have a higher speed of the light ray. So this is changing of the speed of the light from air to water, causing the light refraction. Let's continue. The apparent shapes of the position. When you are going in the boat and you're going to see or look at the fish under the sea, you are going to have an apparent position of this fish. Why? Because due to the reflection of the light which is coming from the sun, as it will be moved through the air and then through the water. So it will be far away from the normal line, and our eyes will see the extension of these light rays. So it will not be the real position of the fish. Let's continue. So when I'm going to ask you to pick up the coin which has been falling at the great depth of the water, you must look vertically, not horizontally. Vertically, it means from this position. If you look at this position, you will have an apparent position of the object. Why? Due to the speed of the light in the air is lower than the speed of the light in the water. Let's continue the last phenomenon, which is the mirage. The mirage is a natural phenomenon that takes place on the deserts or the roads at the noon, especially at the summer time. When you are in the traveling on the high road, you imagine that there is water at the end of the road, but this is not real. This is the mirage phenomenon. What happened or what is related to the mirage phenomenon? It's related to the light reflection. as we have the upper layers of the air which have the higher temperature and the lower layers of the air which have the lower temperature. When the light of the sun falls on these two different layers of the air of higher temperature and the lower temperature, it will causing the light refraction of the light, and this causing the mirage. So the reason of the mirage is related to the reflection and the refraction of the light. We have finished the second part of this lesson, the light refraction. I hope that you study it very well, and I will cover you with the model answers for the booklet exercise. Study it very well and solve the exercise in your booklet. Goodbye.